Hi guys, so today we're going to talk about Chapter 4, Section 1, Factors and Prime Factorization. Now, before we get started with the lesson, I want to start off with a review question. So the question is asking you to write 24 as a product of two whole numbers in all possible ways. So for example, I provided one already, which is 1 times 24 is equal to 24. So those two whole numbers, 1 and 24, are two possible ways to multiply together to equal to 24. Now what I want you guys to do is to write other possible ways to get the product of 24. And I'll give you a few minutes to work on that starting now. Okay. So again, we already know that 1 times 24, that equals to 24. We also know that 2 times 24, or not 2 times 24, but 2 times 12, that equals to 24 as well. There's also 3 times 8, that equals to 24. And the last one is 4 times 6, that equals to 24 as well. And so from here, what I want to do is I want to write down all of the numbers that I used to get to 24. There was 1, 2, 3, 4, 6, 8, 12, and 24. And what we call these numbers are, all the numbers are called the factors of 24. Factors of 24. And the reason why we call them the factors is the first vocabulary word for today, which is that factors are numbers you multiply together to get another number. So the factors of 24 would be all the numbers that multiply together to equal to 24. There's different types of prime numbers and composite numbers that will use factors. So for example, a prime number is a whole number that is greater than 1 and has exactly 2 whole number factors. For example, a prime number could be the number 5. Number 5, the only 2 factors you would have for number 5 is 5 times 1. And you can also determine what a prime factor is by checking it by thinking about what the number divides by. So for example, you have here the number 7. Number 7 can only divide by 1. There's no other numbers that 7 could divide by. And so because of that, we say that the number 7 is prime. It's a prime number because there's nothing else that can divide by 7 other than the number 1. The other type of number that we're going to discuss today is a composite number. A composite number is a whole number that is greater than 1 and has more than 2 whole number factors. For example, a composite number would be the number 12. Number 12 has 6 factors. There's 1 and 12, 2 and 6, 3 and 4. And so because it has 6 factors, we can say that this is a composite number. Now for determining if you have a composite number, for example, let's say if you have the number 21, what you can do is you can see, are there any other numbers other than 1 that 21 can divide by? And I know that 21 can divide by the number 7. That would equal to the whole number 3. And so because it has a number other than 1 that the 21 can divide by, we can say that 21 here is a composite number. Okay, so let's look at a few examples, and you're going to determine whether the number is prime or composite. Okay, so the question here is asking you, is the number 9 prime or composite? I'll give you a few minutes to work on this on your own first. Okay, so the number 9. I know that 9 can also divide by 3. And when 9 divides by 3, that equals to 3. So I know that it has more than one factor. Or sorry, more than 2 factors. And so because of that, I'm going to say that 9 is a composite number. Now let's look at the number 17. Is this a prime number or a composite number? Again, I'll give you a few minutes to work on this on your own first. Alright, so is 17 prime or composite? Right here, we do have the number 17. I don't think, and there isn't a number that is able to divide by 17. 2 doesn't work, 3 doesn't work, 4 doesn't work. No number works to divide by 17 and get a whole number. So because of that, the only answer I have is that, well, 17 is only able to divide by 1. And because it's only divided by 1, that means this would be a prime number. Okay, let's try out one more example. Right here we have the number 41. Is 41 a prime number or composite? Okay, so if we're checking out if 41 is a prime or composite number, I'm gonna think about it. There are no numbers. There's 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work. No numbers work to divide by 41 other than the number 1. And so because 41 is the only one that, the number 1 is the only one that can divide by 41, we have to say that 41 is a prime number. Okay? Now, the reason why we need to know this vocabulary is for our goal for the day. So the goal for today is to identify all the prime factors that could make up a composite number. So we want to look at all the different prime numbers, and if they were to multiply together to make this composite number, what would those prime factors be? So the way that we can write out all of the prime factors and identify them is by using a factor tree. The factor tree helps us to find all the prime numbers. So for example, right here, we're given the question to write the prime factor of 32. So I'm going to start off by writing down the number 32. And I'm going to think about all the different types of numbers that could multiply to get 32. So since 32 is an even number, I do know that 2 could work. So I'm going to use 2. I don't know what 2 would be though. So let's see. 32 divided by 2 would give me 1, 2, 12, 6. So 16. So I do know now that 2 times 16 would give me 32. I know that from 16, 4 times 4, that equals to 16. For the 4, I do know that 2 times 2 equals to 4, and 2 times 2 equals to the other 4. Now, if you notice, whenever I stopped at a prime number, I never expanded more into that number. I just want to keep it, once I see that it's a prime number, I just stop. I don't create that split between them and try and find different other ways to multiply. And so what I'm going to do next is circle all of the prime numbers that I see. And it turns out that all the prime numbers are the number 2. And I have 1, 2, 3, 4, 5 2s. And so what I'm going to do is just list out all those 2s. So I have here 2 times 2 times 2 times 2 times 2. And since I see that we have multiple 2s, I could create an exponential form of this layout here. And so since I know that there are 5 2s, then I could write the exponential form 2 to the power of 5 because 2 is being repeated 5 times or is being multiplied 5 times. And so the prime factors of 32 is 2 to the power of 5. So I can write that as my answer. The prime factors of 32 is 2 to the power of 5. What I did was I found out all the different prime factors that make 32. So if I were to multiply 2 times 2 times 2 times 2 times 2, you would see that this would be 4 times 2. This turns into 16. 16 times 2 equals to 32. So whenever you list them out, all of these prime factors should equal to the number that you're looking for here. Okay. Now let's try out some problems on Get More Math. Okay, so the first question is asking us here, what is the prime factorization of 111? So let's look at 111. Now, I don't know what numbers could multiply to get 111. One thing that does help me out is by identifying, is this an odd or even number? I can see here that this number is definitely odd. So that means that we cannot be dividing by an even number. So we can't divide by 2. That wouldn't work out. An odd number could work out, maybe like 3. Let's see if 3 works. So if we have 3, let's see if we could divide by 3. 3 would give us, 3 times 3 would give us 9. And then I'm left with 2, and then I drop down the 1, and I get 21, so 3 times 7, that equals to 37. So 3 works. So I could say here that, well, 3 times 37 works. If I were to look at 37, let's see, let's try out 3 again, see if that works out. We have 1, 3, that turns into 0, drop down, that's 7. We get 2, and that turns into 6. And then we have to start using decimal points. So because we have to start using decimal points to find out our number, that means that it's definitely not going to work out if we have a decimal point. So that doesn't work. Maybe 5, that wouldn't work out either. 7 doesn't work. So because of that, we have to say that I'm pretty sure that this is a prime number. Same for number 3. So both 3 and 37 are prime numbers, and that's where we're going to end. So what is the prime factorization of 111? What I would write here is 3 times 37. And let's see if that works out. Nice. So we got a point there. Let's look at this question. Choose the best word for this number. So we have number 17, which is actually cool because I think that was one of the questions that we got earlier. So is number 17 prime, composite, or neither? We do know that 17 cannot be divided by any number other than 1. So I'm going to say that this is a prime number. Over here it says, which of the following is a factor of 46? So when they're asking this, they're asking what number can we divide by that equals to 46 here. So let's check out 31. Can 31 divide by 46 and receive like a whole number? Let's see, if I have 31, 46, I would have to use 1. So that would be 31. This would be 5, 1. I would have to use decimal points now, and so because I have to use a decimal point here, then we have to say here that no, this probably is not going to be, able to divide into 46 properly. And so because of that, we're going to say that 31 is definitely not one of those factors. What about number 6? So 46 divided by 6. Let's see. 6 divided by, 46 divided by 6. There's 7. 7 times 6 gives us 42. Then we get 46 minus 42, that equals to 4. So that doesn't work out either because, again, we're going to have to use decimals. And so that means that we're not going to get a whole number answer. So because of that, we have to say that 6 does not work out. How about 46 divided by 23? If I were to use this, 23 and 46, we could use 2. 2 would give us 46, and it would be a whole number. And so because 46 divided by 23 equals to 2, we would have to choose 23 as our factor. Let's see if that works out. Nice. Okay. So this is how you would answer the problems on Get More Math. If you have any other questions, feel free to ask me during office hours. Other than that, I wish you guys good luck.